Hey Algebra 2, it's been a while since we had a video. If you forgot any of your old stuff, I recommend just watching some of the older videos to catch yourself up. But what we're going to do today is talk about log properties. So, log properties. So before we even talk about log properties, let's talk about what were the exponent properties. For example, if you remember, x to the third power times x to the fifth power, you would add those exponents together. So it would be x to the eighth power. So logs have a similar property. Now remember, the opposite of exponent base are log base. So their properties are still the same. So here is the first property, which is called the product property. And I'll put that up here. Product property. First one is that if you had a log of whatever base, and let's pick two different numbers. So let's call it m and n. So if there's two numbers being multiplied inside the log, so this is inside the same log, I can rewrite it as two separate logs being multiplied or being added. I apologize. So let me re-say that all together. If they're being multiplied in the middle, then you could add them by separating. Multiply together, add separate. Let's look at this. This is multiplied separate, then they're added together. Multiplied together, added separate. So what does that mean? I'll give you two examples of this property. Let's do log base 3 of 10 times 5. Okay. Well, log of m, the first number, is 10. So log base 3 of 10 plus log base 3 of 5. The base has to match the original base, and they're going to be the same one, so they're just going to make copies of it. So there's your first example. Log base 3 10 plus log base 3 5. Another example, I'm going to use ln. Think for a second, what does ln stand for? That is the base, a log with a base of e. So I'm going to do ln 21. Now you can look at that, you say, well, Mr. Tobel, 21 is a number, just like a whole number. Like there's not two numbers there. But what are two numbers that can multiply to 21? The only answer you should have is 7 and 3. I guess 1 and 21, but let's talk about 7 and 3. So I could rewrite this as ln 7 plus ln 3. So even whole numbers, I could break down to their factors, 7 and 3, and write them separately. That's going to be important later for a later question. Let's get to the next property. The next property is going to be essentially the opposite. X to the fifth divided by x to the third equals x to the second. In logs, what happens if you have log m divided by n, you could rewrite that as log m minus log n. So you could separate them. Log m minus log n. Pretty important. The denominator is going to be the one subtracted. And it has to match the same log. So if this was log base 3, they all have to be log base 3. That's also important. Okay, so let's give two examples. And this is called, I mean, it should be obvious what it's called, but if in case you don't remember the word, quotient rule. You could put log quotient rule. If you want to Google that later, you can do that. Okay, so two examples, one with separate numbers. So let's do log 10 divided by 7. Can't really simplify that, but I can rewrite it as log 10 minus log 7. Quick little recap or a little reminder. Remember, if you don't see a number on the bottom, what is this number on the log? If we don't see a number in the base of the log, what do we assume it is? The right answer should be 10. So it should be log base 10, 10. Now tell me, what happens when you have a log with the base and the number being the same? Well, they cancel out. So you cancel these out, and all you're left with is 1. 1 minus log base 7. So this is a reminder from 4.4. And hey, looks like we made it a little bit more simpler. It's just 1 minus log 7 versus log 10 over 7. That's kind of the purpose. We're going to rewrite these in order to make it a little different. Okay? Another one, let's do log, let's do 6. Now, technically there's a million ways I could divide into 6. So I'm just going to pick one. Let's do log 12 minus log 2. Because let's check this. 12 divided by 2 does give me 6. So I can rewrite 6 as 12 over 2 and then separate it. And again, I'll give you reasons why we're going to do that in the example problems. But we got one more property. Our last one is when you have an exponent and exponent. So exponent to exponent, that's going to be x to the 15th. So you multiply. So when you have a power to a power, you multiply, and that's called the power rule. So how does that work in log? It's a little different. Log of m to the n power will become n times log m. So essentially, when you have a power within a log, you could take whatever that exponent is and move it to the front. So this is your equation. So let's just do one example. Log 15 to the third power. Well, 3 is an exponent within logs. So I could take that 3, move it in front. So now it just becomes 3 log 15. And that's it. So the power rule is very simple. Essentially, you could think of it like this. If you have an exponent within a log, move the exponent in front. So now we're going to do today's practice problems, which I kind of call them puzzles because you have to figure out what and how you use the pieces. So let me erase this and let's start the process. All right, so let's start this problem. This right here is going to be given. And for these type of problems, I have to give you something. So let me just read it out for you. Log base forward 3, so normal size 3, equals this decimal, 792. And log base forward 7 equals 1.404. So right here is your given information. What we're going to do with this given information is do a little bit of math and try to figure out how to solve each problem. So let's do problem number 1. Log base 4, 7 divided by 3. Okay. Log base 4, 7 divided by 3. If you remember from the last section, we usually would make this x and then rewrite it as 7 over 3 equals 4 to the x power. But look at that. There's no way, I don't know, and I doubt anybody here knows, what 4 to the x power becomes when you do 7 over 3. Like what number, what decimal I have to put in there. So we can't do that on this test, or this section, I should say. So let's talk about something else. Log base 4, 7 over 3 equals x. How are we going to take care of that? Well, this is what we're going to do. Let me see. I know log base 4, 3 is, and I know what log base 4, 7 is. Very quickly, you can't just do 1.404 divided by 0.792, because this is not log base 4, 7 over 3. That's not what you could do. I could rewrite this as this from our rule earlier, our quotient rule. I have to rewrite it as log base 4, 7 minus log base 4, 3. I have to rewrite it because remember, 7 over 3 is not equal to 3 or 7, so I can't just replace that. Wait a second. Look at this. I know what log base 4, 7 is. And I know what log base 43 is. Log base 47 is up here, 1.404. Minus, hey, I know what log 4 base 3 is, 0.792. So we got log 1.404 minus 0.792. We set that equal, and now we could do a simple subtraction problem that anyone could do in their calculator, which is 0.612. So your answer is 0.612. So these quotient rules over here, or that we learned earlier, will help us figure out. I'm going to use the same given for another problem. All right. Log base 421. Log base 421. Here's a big issue. I don't see no 703 in this. So I want you to give me a guess what we have to do with this 21 in order to start making it look like our givens. Well, if you remember from the examples, I used an exact number. By the way, on accident, I didn't actually remember that this is going to be my example problem. But 21, I could rewrite that as something. I could rewrite that as 7 times 3. And let's check. 7 times 3? Well, yeah, that is equal to 21. Hey, since I just rewrote that, I can rewrite this whole thing as log base 47 plus, with the product rule, log base 3. Wait a second. I know what log base 47 is. And I know what log base 43 is. So now I can substitute this. Log base 47 is 1.404 plus this one is log base 3 is 0.792. When you add that together, you get 2.196. So let me recap because I fell a little fast. This was the problem given to you. You, as the person who's trying to solve the problem, is thinking, how can I take this 21 and break it up into pieces? Into something I do know, or what I'm given. Since I know 3 and 7, is there a way I could break up 21 into some amount of 3 and 7s? Yeah, 3 times 7 is 21. So I rewrote 21 as 7 times 3. So that equals log base 47 plus log base 43. After I break it up into these two pieces, and you see how I circled them? These matches my given. So now I could do both. 1.404 plus 0.792 equals 2.9196. So I'm allowed to break it up or replace them after I get them to the perfect match, okay? I'm going to do at least one or two more. Same given, so you don't have to change anything. So before I go on to the next practice problem, I want you to put this somewhere in your notes. I don't remember if we did this in the last section, but I'm just going to mention it. Log, it doesn't matter what number here, so I'm going to put B. 1. What does that mean when it's log any base 1? What does that mean that's going to end up equaling? So let's set it equal to x. So 1 equals x to the b. Okay, what exponent do you make any number into 1? Well, any number that you plug in will make that into 0. So what that means is that log any base, so we use b for any base of 1, always equals 0. Because you got to think about it. 1, no matter what the base is, to the 0 power, will become 1. So that's why if you have log base 1, that automatically equals 0. I don't remember if we did that last section, so I'm just going to mention it now because it's going to be relevant to the last example. But before we get to the last example, let's do an example before that. Let's do log base 4, 49. Okay. So let's look at it carefully. Log base 449. So we need some combinations of 7 and 3. I'll give you 5 seconds to think. What is the combination of 7s and 3s? Can you get to 49? Well, 49 is the same as 7 times 7. So I'm going to rewrite this as log base 4, 7 times 7. Because 7 times 7 gives me 49. Since I rewrote it like that, they're multiplied together. I could write them as added separately. So log base 4, 7 plus log base 4, 7. I know what log base 4, 7 is. That's 1.404 plus, I know what log base 4, 7 is. That's 1.404. Now, I can easily use a calculator, or I'll just use my head in this one. This ends up being 2.808. So what happened here? I took my log base 449 and broke it up into pieces I know. So over here, I broke it up into pieces of log base 3 and log base 7. From there, because I broke it up into two 7s, multiplied, when they're multiplied together, I could write them as adding separately. Since I wrote them adding separately, this was a matching guy and this was a matching guy. So then I was able to substitute it to get my answer. My last example, which is going to involve that log base 1, is going to be, let's do it live. So let's do log base 4, 1 over 3. So look at that, a fraction. But don't worry about fractions here. Okay, so it's log base 4, 1 over 3. So how does that affect my question? Well. Since this is a division divided together, the quotient rule allows me to write it as separate. So the subtraction separate. So log base 4 of 1 minus log base 4 of 3. Now, if I didn't just tell you this, I would ask you, oh, what is this? Log base 4, 1. We don't have this in the box. But you have to remember, any log 1, no matter what the base is, ends up being 0. Because remember, the exponent 0 makes any number 1. So the reverse is true. Any log that's 1 will end up 0. So I know log base 4, 1, let me use a circle, is going to be 0 minus, wait a second, I know what log base 4, 3 is, so I can circle that piece. So that is 0.792. Well, 0 minus the negative of this will just simply be negative 0.792. So that is your answer for this one. Okay. So that is the work. Let me just check your homework. I'm going to give you a problem that looks like this, so let me just do it here. How can I do this? What was that one? Oh, okay. So, what if I gave you a problem like this? So here is just a practice for the homework, particularly 3 to 6. What if I gave you a question like this? Tell me, what is log base 11? No, base, let's do 12 minus log 3. So remember, if they're minus separately, I could do the reverse. I could combine them and make them division. So log 12 over 3. Now, does 12 over 3, 12 divided by 3, simplify to something? Yeah, log base 4. Okay? So why am I showing you this? This is the reverse of the rule, that you, when they're minus separately, you can divide them. So I'm going to look at one of the questions in your homework. You have something like this. I'm going to pick number 4. 2 ln 6. This is number 4 on your homework. So you can use this to help you find it. So 2 ln 6. Remember, the exponent rule is that when you have a number to the exponent, so ln m n, you could move it to the front. Well, hello, that would mean the reverse is true also. So now I could rewrite this as put this guy on top. ln 6 to the second power. ln 6 to the second power, that's ln 36. Look at question number 4. It asks you to match which one that works with. That matches ln 36 with letter D. So your answer for number 4 is letter D. Okay? Not a lot of homework tonight, but a little longer of a video, so I apologize for that. All right, good luck. I'm going to host a Zoom session for questions on this. Otherwise, have a wonderful day.